Good morning, everyone. Today we're going to be talking a little bit about fractions. Specifically, how do we take a mixed number and rewrite it as an improper fraction? Now, what is a mixed number? Well, a mixed number is going to be something that looks like this, 2 5/6. And it's called a mixed number because we're sort of mixing notations between writing as a traditional fraction and writing as a whole number, and we're mixing these together into one to say 2 wholes and 5/6. Now, this is in contrast to an improper fraction, which is something like 17/6, where the numerator here is larger than the denominator, saying that we have more than one whole, more than just 6/6, which would be equal to one whole. But let's actually dive in a little bit here into what it really means to have 2 5/6, and I think that's going to help give us a clue of what we can do to translate this 2 5/6 from a mixed number to an improper fraction like 17/6. So when we say 2 5/6, we quite literally mean 2 wholes, as in these 2 whole rectangles. 2 wholes. Right, and I can fill these in, and I'll use green to fill each of these in. And 5/6 of a rectangle. And I'll represent that on the right over here by taking 5 of these 6 pieces. Right? Each of these rectangles is broken up into 6 pieces, so each of these little rectangles represents a 6. And so on the right over here, we have 5/6. And so in total, this picture represents 2 wholes, which we have on the left, and 5/6 on the right. Now, since each of these rectangles is broken up into 6 pieces, we can count the total number of sixths by just counting the number of little rectangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And so what that tells us is that 2 5/6, right, our 2 wholes over here on the left plus our 5/6 over here on the right, is going to equal 17 of those pieces, 17/6. And that's generally the idea of what a mixed number represents and how we can interpret it as an improper fraction. Now, it might be a little bit tedious to draw out those rectangles every time, but the principle still remains. And so let's take a look at another example. Say something like 4 4/9. And so this time we won't draw out 5 different rectangles, each broken up into 9 pieces to represent 4 4/9. But we can still keep that in mind as we work here. Right? When we had the rectangles before, we had 2 wholes, which gave us 12, or 2 times 6 of those pieces, plus the extra that were remaining. And so we can apply that same here, right? 4 wholes is going to give us 4 groups of those 9 pieces, 4 groups of 9, or 4 times 9, which is equal to 36. And then our additional 4/9 is going to give us 4 more of those pieces. And so when we add those together, 36 plus 4, we have a total of 40/9. And so in conclusion, we would say 4 4/9 is equal to 40/9. And the more you work with this, the more you'll start to realize there's a really nice pattern here. Let's say we had something like 6 7/12. Well, we've still got the same idea. If we want to figure out how many twelfths we have, right, how many of those pieces, when we break our whole up into 12 pieces, that we'll have, we have 6 wholes, so that's 6 groups of 12, or 6 times 12. plus the additional 7 that we have over here, which will give us a total of 6 times 12, or 72, plus 7, which is equal to 79 twelfths. And so we'll say in conclusion that 6 and 7 twelfths is equal to 79 twelfths. So what the process ultimately comes down to is when you're given a mixed number like 6 and 7 twelfths, we want to figure out how many twelfths there are, and we'll do that by taking this 6 here and multiplying it by this 12 to give us how many twelfths live here, and then adding that additional 7 on top of it. And that'll give us the total number of twelfths, the total number of pieces of our whole. I hope you found this video helpful. If you do have any questions about this or other topics, feel free to post those in the comments below. Thank you guys for watching, and yeah, have a great day.